I'm so glad we practiced all that factoring because today we're going to factor to solve equations. If you had x squared minus 3x minus 4 equals 0, you could certainly do the quadratic formula, which eventually we'll practice. You can complete the square, or you can factor to solve it, which is the fastest way. So if things are factorable, if you remember how to factor, you will save yourself so much time. So we are going to find the zeros. We're going to find the answers that you can substitute in for x that make the equation true. So if we look, it ends in minus 4. I know that means it has to be 1 plus and 1 minus. The factors of 4 could be 1 and 4 or 2 and 2. Which set is 3 apart? The 1 and the 4. So to make it add up to negative 3, it has to be negative 4 and plus 1. So here's the equation factored. We have to solve it. So what is 0 times anything? That's right, 0. So if I can get the left parenthesis to equal 0, it doesn't matter what the right one is because 0 times that will equal 0. Same thing over here. If I can get x minus 4 to equal 0, it doesn't matter the other set of parentheses. It'll work out because 0 times whatever is 0. So we're going to set up two equations here. X plus 1 equals 0 and x minus 4 equals 0. Now, x plus 1, we would just subtract the 1, and x equals negative 1. Maybe? Okay. So that's one of our answers. Over here, x minus 4 equals 0. We'll add the 4. 0 plus 4 is 4. Now, eventually, you'll start to notice a pattern here where you won't even need to set up the equation sometimes. If you look back here where it was factored, it said x plus 1. Our answer turned out to be negative 1. It said x minus 4. Our answer turned out to be positive 4. So it's always the opposite of what you see factored. So maybe keep that in mind, save yourself a little bit of time later. All right, example 2, and it's really lagging. All right, k squared plus 24k plus 144. Factors of 144 that add up to 24 would be 12 and 12. Now, if we were properly factoring k plus 12 times k plus 12, I would say k plus 12 squared. But in this case, it's not going to make a difference. Now, you can set up the equations k plus 12 equals 0 and k plus 12 equals 0. It's the same equation, so we're going to end up with the same answer. So we can just set it up once. K plus 12 equals 0. We'll subtract our 12. And k equals negative 12. So we only ended up with one answer on that one. So if this was graphed, this parabola would only hit the x-axis at negative 12. It would only hit at one point. The solutions for these are, where would the parabola cross the x-axis? 5x squared minus 13x plus 6. This is a little more complicated to factor. So, common factor, no. 5 times 6 is 30. Factors of 30 that add up to 13 will be 10 and 3. So it would be x minus 10 and x minus 3. But don't forget, we have to try to divide them by that first term, 5. So this would be x minus 2. And then this one, you kick the 5 to the front. It becomes 5x minus 3. Now this first one, x minus 2, we know that x would equal positive 2. The 5x minus 3 is a little more complicated. So again, once you get comfortable with these, you can do the two steps in your head, but let's write this one out. 5x minus 3 equals 0. So first, we would add the 3. 5x equals 3. And then we would divide by 5, so x equals 3/5. If you substitute either of these answers into the original equation, they both work. Now remember how I said it's always the opposite, like here? If you look, So we had to solve 5x minus 3. We ended up with 3/5. Check it out up here. It says minus 3/5. So if you want, at a certain point, if you're solving these, you don't even need to kick the 5 to the front. You can look at that fraction and think, oh, well, the opposite. It says minus 3/5. So our answer would be positive 3/5. It's an option for you. It's an option. 81n squared minus 16. Hey, those are both perfect squares. And there's a minus in the middle. So we could say 9n plus 4 and 9n minus 4 equals 0. So here, you could set up two equations. 9n plus 4 equals 0, 9n minus 4 equals 0. But let's try to do a little bit in our head here. If I was solving 9n plus 4 equals 0, what would you do first with the plus 4? You would subtract 4, so it'll be negative 4. And then what would you do with the 9? You would divide it. So we'd have negative 4 ninths. If we kind of thought that same process, here, 9n minus 4, you would add 4, positive 4, then you would divide by 9, so 4 ninths. Cool. If that way is not going to work for you, then write out the equation and actually show the steps. But I think for some of you guys, you could be all right not showing those steps and still get the same answer. Always look for a common factor. Negative 3b squared plus 3b plus 9 equals 0. The first term is negative. We have to factor out a negative. Also, 3 goes into all of these. So if we factor out negative 3, we have b squared minus b minus 9. Whoops, not 90, 30. Now the nice thing about if you're just solving these and you don't have to factor it all the way, the greatest common we factored out already doesn't make a difference. So we can kind of ignore the negative 3 on the outside. Don't worry about it. If we're factoring what's inside, ends in negative, so it has to be one of each. Factors of 30 that are 1 apart would be 5 and 6. They have to add up to negative 1 and be negative 6, positive 5. Now I'm just going to write the negative 3 on the outside, but again, it won't make a difference when we're looking for the solutions here. I see b plus 5, so b equals negative 5. b minus 6, b equals positive 6. If you substitute either of these answers into the original equation, they both work. And these are the only numbers that work. All right, number 6, 16x squared equals 8x minus 1. We're going to have to get everything on the same side of the equal sign. So we're going to move it all to the left. 16x squared. To move 8x to the other side, you have to subtract it. To get the 1 to the other side, we'd have to add it. Because you have to have them equal to 0 to do this. So I might have to pause here if they make an announcement. I think we're good. Can I square root the first term? Yes. Can I square root the last term? Yes. So maybe it's a perfect square trinomial. Square root of 16x squared is 4x. Square root of 1 is 1. We'd have to put a minus in the middle because you have a minus with the 8x there. Double check. 4x times negative 1 times 2 gives you that negative 8x. So we're good. We factored it properly. Now think of the equation. 4x minus 1 equals 0. You would add the 1, positive 1, and you would divide by 4. So x equals 1/4. That is the only solution on this one. We got to simplify on this one. So we will add, where are we going? There we go. We'll add a y squared over here, so that'd be 3y squared. We'll subtract a y, so it'd be negative 5y minus 8 equals 0. So we just got everything on the same side of the equal sign, combined our like terms. No common factor, so if we did 3 times negative 8, it'd be negative 24. Factors of negative 24 that are 5 apart would be the 3 and the 8 that we just used. So y minus 8, y plus 3 Don't forget we have to try to divide them by that a, which in our case would be 3. Now, let's try to shortcut when we can. Now, if we factored, yes, the 3 would go to the front, which we'll write that in a minute. But look, it says y minus 8/3. The answer will be positive 8/3 then. Right, so there's one. We'll write it in proper factored form too. 3y minus 8. And then here, 3 over 3 is 1. So y plus 1, which means our other y would equal -1. I might have to stop here just in case. I mean, you never know. Oh, I think we're good. Okay, sorry. I just... All right. I think we have 4 more. X squared. Now, write it in intercept form and give the function zeros. Sure. Same thing. So whether it says 0 equals this stuff or y equals this stuff, we're still looking for like, where is it crossing the x-axis? Oh my goodness, I'm just going to pause.
Forward, Triana